Assalamualaikum everyone. In this video, we'll see the introduction to partial fraction, or more likely an overall view of the partial fraction, what all we are going to study in this chapter. Okay, in your elementary algebra, your 7th, 8th standard, you might have studied about fractions, right? Suppose you are given two different fractions. Suppose I've got 2x by x plus 1 plus 3x by x minus 1, right? You've got two different fractions. It is separated with a addition sign, right? You're going to decompose this. You're going to reduce this into one single fraction, one single unit. These two fractions, you're going to reduce it to one single fraction, right? You might have studied this. Now, the opposite of this, I'll be given one fraction. I'll decompose it into two or more, a series of fractions, okay? Separated by an addition or subtraction or multiplication, anything. So the opposite of this, I'm given one fraction, I'll decompose it into two or more different fractions. So the definition, a process of separating a fraction into a group of simple fractions is called as a partial fraction of the given fraction. Okay, so this fraction is being reduced into two or more different fractions. These individual fractions, this 2x by x plus 1, or this individual fractions are nothing but my partial fractions. Okay, this is what we are going to study in this chapter. It is very simple. One fraction will be given, we are going to decompose it. Okay, next, rational fraction. I'll just erase this one. Now, rational fraction. If f of x and g of x are two polynomials, we have got two polynomials. One is f of x and the other is g of x. Okay, if these two polynomials, this is one polynomial, this is one polynomial. If these two polynomials are in the form of f of x by g of x, matlab p by q form, it is called as the rational fraction. Okay, if these two are in the form of a fraction, that is p by q form or like this, then it is nothing but a rational fraction, a fraction, right? And one condition is given, that g is not equal to 0, because g is a denominator, so it will not be equal to 0. F of x is the numerator and g of x is the denominator, right? Simple. Now next, rational fraction is further divided into a proper fraction and an improper fraction. See, proper fraction says that the degree of g of x is greater than the degree of f of x. Okay, if the degree of g of x, that is the denominator, is greater than the degree of f of x, that is the numerator. Okay, degree means the highest exponent, right? For example, I've got this 2x cube plus 3x square plus x plus 1 equal to 0, right? In this is my exponent, 3 is my exponent, 2 is my exponent, I've got nothing here, means it is 1, so 1 is my exponent. So among this 3, whichever is the highest will be the degree of this polynomial, right? So 3 here is the degree. Clear? We'll see the example. See here, 3x plus 7 by x square minus 3x plus 2. Here if you see, the numerator is having degree 1 and the denominator highest degree is 2. So 2 is greater than 1, right? The denominator is greater than the numerator, so it falls under proper fraction. Next, here the degree of numerator is 1, the degree of denominator is 3. So 1 is less than 3, right? I mean 3 is greater than 1, that means it is a proper fraction. The denominator is greater. Similarly here, the degree of numerator is what? 2. And the degree of denominator, this x square will be multiplied with x, will give you x cube. So the degree of denominator, that is highest degree, is cube, that is 3. So 3 is greater than 2, right? That means the denominator is greater than the numerator. So these are nothing but my proper fraction. These type of problems falls under proper fraction. Now moving on to improper fraction. The opposite of proper fraction is nothing but an improper fraction. See, the degree of g of x is less than or equal to the degree of f of x. One will be greater than, the other will be equal to, and the next will be less than. So this is done. Now these two are remaining, right? Less than unequal to, less than, unequal to. So the degree of g of x, that is the denominator, if it is less or if it is equal to the degree of numerator, then such question falls under improper fraction. Okay, see here, the degree of numerator is what here? The highest degree is 2. Now in the numerator, if you multiply x into x, will be x square. So the degree is 2. So 2 is equal to 2, right? So this falls under improper fraction. Now next here, the degree of numerator is what here? 4. The denominator, x square into x will be multiplied, so it will be x power 3. So the highest degree here is 3. So see, 4 is greater than 3. That means the numerator is greater than the denominator. So such question falls under improper fraction. Okay. Now, if I am having a proper fraction, how am I going to reduce into partial fractions? Okay. How am I going to, if I got a proper fraction, how am I going to separate it? How am I going to break it? Okay. With the help of these 4 different types. See. Type 1, this all types, type 1, 2, 3 and 4, it will depend on the denominator. Okay? It will depend on the denominator. If the denominator, that is g of x, if it contains a non-repeated linear factor, okay? If I've got a simple factor, suppose x minus 1, it is linear, it is not quadratic, the power here is 1, it is linear and it is simple. So if the denominator, suppose this is the denominator, and I've got suppose anything here, 1 or 2x or anything. So if the denominator is simple and linear and it is not repeating, here x minus 1 is the only term, it is not repeating. So such question falls under type 1. Okay. Now next, type 2. G of x contains repeated linear factor. Suppose x minus 1 whole square if I have. So here x minus 1 is the term which is repeating 2 times. So here it is a linear factor and it is repeating. So it falls under type 2 category. Now type 3. G of x contains irreducible quadratic factor. I think you know what is a quadratic factor, right? The polynomial with the degree 2. Suppose I have got x square plus 2x plus 1. Okay, if this is my quadratic factor, if it is not reducible, if I can change it into a linear factor, suppose I am saying x minus 1 into x plus 1, anything like this, if I am able to change it, so it falls under type 1 or type 2. But if I am not able to reduce it, if it is irreducible, then it falls under type 3 category. In type 3 category, we have a quadratic equation which is not reducible. Okay? A quadratic equation which is not reducible. Suppose in type 2 or type 1, you have got a quadratic equation, but it can be reduced to a linear equation, then it will be type 1 and 2. Okay, we'll see this in detail in the coming videos. We'll see in detail what is type 1, how do we solve this if the denominator is not repeating in linear, if the denominator is repeating in linear, if it falls under type 1 or 2, how we are going to solve them. Okay, this is identifying. The next step will be solving it, right? So we'll see that in detail in the coming videos. Now coming to type 4, g of x contains irreducible repeated quadratic factors. Here I have got a quadratic factor, it is irreducible and also it is repeating. Okay, suppose I've got a quadratic factor like x square plus 3x, and suppose it is repeating 2 times. Whole square means it is repeating 2 times. So such question falls under type 4 category, right? G of x, only we are considered about the denominator. Okay, we are concerned only about the denominator. This denominator, g of x is nothing but a denominator, right? So if it is not repeating linear, it is type 1. If it is repeating linear factor, it is type 2. If it is quadratic and it is irreducible, then it is type 3. If it is quadratic, it is irreducible and repeating, then it is type 4. That's it about proper. Now comes to improper fraction. Improper fraction, right? The degree of the numerator is lesser than or equal to the degree of numerator, right? So this questions, for solving these questions, first we need to convert it into a proper fraction. We cannot solve these problems directly. We need to first convert it into a proper fraction. Then depending upon the denominator, we have got 4 different types for this. Okay, so this improper fraction, with the help of long division method, we are going to convert it into a proper fraction. I told you this should be converted into first proper fraction. with the help of what? Long division method we'll be using. So improper fraction with the help of long division method is reduced to proper fraction. Then depending upon this proper fraction, the denominator, we have got 4 different types. We'll pick that one, we'll pick one and then we'll solve it accordingly. Okay, so I think I'm clear with this partial fractions. These all are what we are going to study in our partial fractions chapter. Okay, types will be studying, proper and improper will be studying, the definition we just saw. If you are thinking about the use, why are we using this partial fraction? See, a complicated thing is getting reduced into simpler things. So performing operations on the simple things, your calculations or your derivations, your integrations becomes easier, right? Especially in electronics or mechanical engineering, you'll be having a Laplace transformations there. So Laplace transformation, you'll be first reducing some Laplace transformations. If you're not able to perform the operations on that directly, you're going to first decompose it into simpler forms, simpler portions. Then you will apply the Laplace formulas to that. Okay, so that's the use of this, and I hope I'm clear with the introduction part. What is partial fraction? What are the different types? How we are going to deal with this? Okay, so that's it for this video. Thank you.